In the last presentation we completed our half adder, and in this we are going to do the full adder. So the one thing which I saw in the last presentation is that the half adder is only used to add a single bit number. It means that if you are adding A and B, then A must be a single bit number and B should also be a single bit number. But in this case, in case of full adder, you can see that I have written a number A which is having 4 bits, A0, A1, A2 and A3, whereas B is also having the 4 bits, B0, B1, B2 and B3. So it clearly means that it is used to add a number, or you can say that two numbers which are having more than single bits. So let me write it down for you. It is used to add more than one bit number, because definitely if you see in your practical life or in your practical world, a single bit is actually a very small quantity, and the nowadays computer are so much powerful and does so many calculations, then definitely a bit stream which is having so many bits are there which is added with the another one. So it is used to add more than one bit number. The another important thing in the full adder is that we are going to make a full adder by using the half adders, or you can say that by cascading half adders, that we will see in a minute. In market you will find the IC, which is integrated circuit for 4-bit and 8-bit full adders. I am not sure about the 16-bit full adder, whether it is available in the IC or not, but I am sure about the 4-bit and the 8-bit. So let's move how the full adder performs the addition. When you add a number having the 4-bit to the another number having the 4-bit, then there is so many possibilities that it is going to generate the carry. Okay, it does not do it always, but definitely there are chances that the carry will be generated. So in addition of the first bit, that is your LSB, and this one is your MSB, A0 and B0, we are going to get the sum. We are going to get the sum, and the sum may be 4-bit and maybe 5-bit. It can happen. So A0 B0 is going to give you S0, and also it will generate a carry. Let's say it is C in, the input carry, and the next addition will be performed between this C in, A1 and B1, and the sum generated will be, let's say, S1, and again there is possibility that the S1 will have the carry, so a carry bit will be added here, and the addition will be in between C in, A2 and B2, generating the third bit of the sum S2. Again there will one carry C in, and the sum S3. So these are the 4 bits of the sum, and if the addition between C in, A3 and B3 is going to generate a carry, then you have to write the carry, let's say C out here, and overall number is going to be C out, S3, S2, S1 and S0, where C out is your MSB and S0 is your LSB. So this is what we do in the full adder, and it will be much easier if I cascade it in the form of the half adders, and half adder is something that you have already done in the previous lecture. So let's move to it. You know, a half adder is having the 2 inputs and 2 outputs. The 2 inputs are, these are, let's make it in different way. Let's make the 2 inputs this way. Okay, so this is B, this is A, the 2 numbers that we want to add, a single bit numbers, and we assume in the half adder the carry input equals to 0, that I have already explained in the previous lecture, and the sum S. So this is our half adder. Okay, now what I'm going to explain you is that how this half adder is cascaded to get a full adder, because if I say that this part is done by one half adder, okay, and then the carry generated, there will be the carry will also be there, okay, and the carry generated will be given to the another half adder. This is our half adder. Let's give them a name. This is our half adder 1, this is our half adder 2, okay, and the carry generated will again given to the next half adder. And till now you have guessed that we are going to use 3 plus 1, 4 half adders to get a 4-bit full adder. Okay, this is a 4-bit full adder and it will be obtained by cascading 4 half adders. So I'm going to make a full adder by cascading the 4 half adders. So let me copy and paste it down. Okay, the second one, then the third one, and finally the last one. Let's make it here. So these are our 4 half adders, and we need to do a little bit of modifications in the name, so that we will do now. Okay, so this will be our B0, A0, C input carry is 0 definitely, and at this place we are having S0. The carry generated will be your C in. This carry C in is generated and given as one of the carry inputs to this half adder, and the bit here is our B1 A1 and the sum is your S1. Fine. And again the carry generated will be C out actually for this one, and when it goes to this it will be treated as C in. Fine. And the bits are B2 A2 S2. This is your C out, this is your C in. C out is for this half adder, C in for this half adder, and it is B3 A3 and S3. Finally we are going to get C out. So I think you now know how a full adder is made, and if I put this circuit in a box, then it can be made like this one, a full adder with the inputs as your AI, BI, these are the two numbers that we want to add, the carry input CI minus 1, and the sum and the carry output. Fine. The carry input is your CI minus 1, this is your carry input, and the carry outputs is CI. Let's see why. Because you can see in this first half adder that the A0 and B0 are the LSBs which we are going to add, and S0 is the sum, and the carry output is what? It is C0, and this C0 is the carry output for this one, and it acts as the carry input for the second half adder. Similarly, this is your C1 and this is your C2. The C2 acts as the input carry for the last half adder, and the C output, this C output is what? It is C3. So you can see that if I say I equal to 3, so the output carry is what? C3 is equal to your C output, or you can say that Ci. Similarly, this 2 is what? 3 minus 1, so I can say that C2 is your C in, which is C3 minus 1 or Ci minus 1, because I is your 3. And you can also check for your A, I and Bi. I is 3, so Ai is your A3, Bi is your B3, and Si is your S3. So this is the generalized form of a full adder. So in the next presentation we will find out the expression, the logical expression for the sum and the carry output by using the K map, and that will be the end for your full adder. So see you in the next presentation.